What happens if every person on Earth aims a laser at the same spot? Could we melt through a thick metal wall, or even blast a hole straight through a mountain? Let's find out. Let's start small with something familiar. The humble 5 milliwatt red laser pointer, the kind used in classrooms and presentations, or to confuse cats. Now, imagine all 8.2 billion people on Earth aim one at the same spot. That's 41 megawatts of power. Sounds impressive, right? But there's a catch. These lasers aren't perfectly focused. Their beams spread out quickly, and by the time they reach the target, they're about 15 meters wide, reducing their strength dramatically. So let's test out what happens if we aim them at a piece of paper. Nothing happened. No burn, no smoke, not even a scorch mark. Just an extremely well-illuminated piece of paper. Clearly, we need an upgrade. Let's step it up. What if everyone had a 1-watt blue laser? The kind that can actually burn things. These lasers are strong enough to melt plastic and set paper on fire. Also, they can permanently blind you if you're not careful. So we'd also need to wear safety goggles to avoid any eye damage. Now, we have 8.2 gigawatts of laser power, enough to power a major city. Plus, the beams stay more focused, spreading to only about 1 meter wide. So, what happens now? Let's see. Finally, we get some action. We can easily set the piece of paper on fire. If we aim at metal, we could even melt a small section of it. But punching a hole through a mountain? Not even close. All right, enough playing around. Let's go big. 100 kilowatt military lasers. These are used to shoot down drones and missiles. If everyone had one, we'd be firing 820 terawatts of power at a single spot. That's huge. These lasers are extremely accurate, being able to focus the beam to a size of just 5 centimeters. Now things get serious. These lasers can vaporize paper and melt through metal. They can even burn meter-deep holes in the ground in a matter of just a few minutes. So what about the mountain? Well, there's a problem. Stone has a high heat capacity, it takes a lot of energy to heat up, and high thermal conductivity, meaning it spreads that heat away. Plus, we can't focus all lasers into one perfect hole. The hole must be significantly larger than 5 centimeters at the beginning, because otherwise the laser beams coming from the side cannot reach the deeper areas. If we point them at the mountain, the first effect would be a tiny, super hot spot where the rock starts to melt. Over time, the rock would continue to melt, and the laser would slowly make a hole, like drilling, but with pure energy. After a while, this process would create a visible hole in the mountain. The heat would crack the surrounding rock, causing it to fall apart. Not very practical, but technically possible. But forget weeks of slow melting. Let's crank things up to 1 megawatt lasers, the kind used for missile defense. Now each laser is 200 million times stronger than the little red pointer we started with. With 8.2 petawatts of total power, we're consuming more energy than the entire world produces. But now, the mountain doesn't stand a chance. At the impact zone, the rock instantly turns to plasma, blasting debris outward like a controlled explosion. This isn't slow drilling, it's more like a continuous detonation, carving through the mountain layer by layer. There's just one problem. The air itself starts to ionize, scattering the laser beams and reducing their power. But even that isn't enough to stop us. Within a few hours, we'd have a tunnel, though it'd look more like the aftermath of a massive explosion than a neat laser-cut hole. So yes, if every single person on Earth had a ridiculously overpowered laser, we could blast through a mountain. But at that point, maybe we should question our life choices. And hey, if you liked this video, subscribe. It's cheaper than a military-grade laser and slightly less dangerous.